let's solve the Leetcode problem. So the Leetcode problem is a maximal product or splitted binary tree. I think these are the three problem set for the Leetcode. We're given the root of the binary tree. Have to split the binary tree into two subtree by removing the one edge, such that the product of the sums of the subtree is maximized. So we have to return the maximum product of the sum of the two subtree. So maximal product mean like is a multiplication of the summarization of the two tree. Since the answer may be too large, we have to return it with the modulo. So also need to note that we need to maximize the answer before taking to the mods, not taking it. So how about we look at into the HTML given by the Leetcode. So to explain that, we have given like inputs like 1, 2, 3, 4, 5, 6, 7. So they are describing the data in the array, but I'm pretty sure we could be receiving the values like a custom data structure like a tree nodes, which include the value left and right. So to move forward to their solution, so they totally split the tree by cutting in the red in here, so which became this is one entity, and the remaining is a one entity. So 4 plus 5 is 9, 9 plus 2 is 11, and then we have 3 nodes. I would say, yeah, 3 nodes remaining. 1 plus 3 is 4, 4 plus 6 is 10. So 10 multiplied by 11 is 110. But there could be the other possibility. What if we split into this is a one side, and then 3 and 6 is a one side. Since the multiplication, total values of the 6 plus 3 is 9, and then 4 plus 5 is 9, 9 plus 2 is 11, 11 plus 1 is 12. So 0, 1. The total is 108. So we can have a like multiple scenario, like we split the tree into many possibilities, and then the maximum value that we could get is 110. That is the reason why we are returning the 110 in here. So how about the second XML? So the same for the second XML. We are splitting the tree into the first part, which involve the 1, 2, and 3, and then 4, 5, 6 into the another parts. So 1, 2, and 3 combination is 6, and then 5 plus 6 is 11, 11 plus 4 is 15. So 15 product times to the 6 is 19. That's the reason why we are returning the 90s in here. So to create that, I have one idea. How about we just declare the variable that we know for the first time? Let's call like mod. I'm gonna write like 1e9, which is going to be the integer. Then I need to cast into the integer. I'm not sure it's a 10 power 9. Yeah, 10 power 9. Then just plus 7. That is what we need to do. After that, we may need the one variable called the total, because we want to return the total values. Yep. So I think since this is a tree problem, maybe we can create some helper function. Like, how about we create the function called sum all, just to summarize all the valuation in the tree like we solved in yesterday. Let's get the value of the nodes, and then we will accept a tree nodes, which is given here. Now we just return back the integer. In here, it's quite simple. So as long as the node is valid, we can go through. If not, we just return the 0. So in here, what I want to do is node of value, which is declared in here, is actual value of the node we receive. And then we just call back our sum of function by calling the left and right. This is quite normal for the tree problem. So at the end, we will receive the total sum of the node. Let's consider we receive the value like 136. So the 1 will enter, so there's no left, there's only right. So 3, 1 plus 3 became the 4. The 4 is go to the left of the next item, which is 6. 4 plus 6 became the 10. We just want that value. That is one of the helper we're going to use. Another thing is we're going to use the default dash. Let's call DFS, which is much better. And then that's going to accept the node also, and then as a tree, which is optional. Now we just return the integer. So I think we can find the total in here first. Not sure we need a total across the variables or not. Let me think about it. But yeah, we need to update it. So we just calculate the total of the whole tree parts, and then we trying to subtract the sum portion of the tree, and then we're going to calculate the best on that. So my idea was just call the sum of for the root. So we got the total values for the whole tree. In this case, like 1, 2, 3 is a 6, 4 is a 10, 5 is a 15, 6 is a 21. So we got the total 21 first. And then from this 21, we're going to detect like sub tree. And then we're going to populate the best solution that. So in the DFS, it's quite similar to the auto tree problem. Let's try to have a type safety. If the node is nil, we just return 0. And then we need to calculate like, let's call like that left sum. That is going to be the df sub, which is going to call our notepad node.left, which is quite similar to the solution we write down yesterday. And then node.right. So after we done for left and right, what I want to do is let's calculate the sum. I just call it sum, and then that will be the node.value plus left sum and right sum. Not sure we could need these very near futures or not. So after we receive the total sum, so it's our time to populate the product. So we're just going to multiplying the sum with by detecting the total. Yeah, total minus sum initially. So initially we're calling the DFS. So this is not going to call all the sum at first. So we can populate like some portion of the tree first. What is the best value we could receive? And then, okay, then we need to keep it like if. How about we keep one value called best? Since without the best value, how are we going to keep track of the evaluation here? Let's call it if the product is greater than sum, so it's true for sure since as initially sum is a 0, and then we're gonna update the best with the product. Yep, just that. I think that's pretty much done for it. Then we just return the sum in here, and then we can directly call the DFS in here. Yeah, I need to populate it since even though we are not using it. DFS of the root. And then just return after modulo of mod. Let's try to run it. What did I do wrong in here? Let me check through it. Yeah, that's exactly what happened to the case that I explained in here. This became the 108. I think I do something wrong during the DFS mode. Yeah, we got the left and right, and we produce the sum, which is the node of value, and then left and right sum. So we got the products, which is the total minus sum. That's also true. What did I do wrong in here? It's supposed to be correct. That's strange. Okay, let's try to debug which is causing the weird things in here. Oh, this could be the best, not the same. Yeah, sometimes I even make a typo, even though I was explaining out of loud, so I cannot complain through it. So I think the time complexity will be the O of n. Yep, since we don't have any other data structure using here, how about the memory? That would be the O of height of the tree, since we are going through like a deficit approach, not the breadth search. Yep. Let's try to submit, see if solved or not. Not sure why it's wrong in the first case. I think it's the previous XML. Cache. Yep. That's all for it, and then see you in the next one. Bye.